we have a couple graphs of exponentials. The red graph is an equation representing exponential growth. The blue is exponential decay. Both of these exponentials have the same general form as an equation, very much related to a geometric sequence. So our equation is y equals the starting number, or the first term, or in terms of a graph, where it's crossing the y-axis, times the common ratio to an exponent. In order to make exponential growth, your common ratio has to be bigger than 1. In order to make exponential decay, your common ratio is a decimal in between 0 and 1. And remember here, your exponential growth or decay are never crossing down into the third or fourth quadrants. The x-axis, or the line y equals 0, is acting as an asymptote, a line that we are never going to cross. The other things we need to know about exponents are all of our laws of exponents, the things we wrote on those colored index cards. So here's the first law: any base to the 0 power is equal to 1. Next law, a negative exponent creates the reciprocal. So if I have 7 to the negative 2 power, that's the same thing as 1 over 7 to the positive 2 power. Or the same thing with a base of a variable. If it's y to the negative 2 power, it's 1 over y to the positive 2 power. Next law, when we're multiplying things with the same bases, you add the exponents. When we're dividing with the same base, we subtract the exponents. When the exponent is a fraction, it creates a radical. The denominator of the fraction tells us what root we're taking, and the numerator of the fraction tells us the exponent, or the power that we're doing it to. So for example, if I've got x to the 2/3 power, that means I'm taking the third root of x to the positive 2. Whereas if I switch this around and go x to the 3/2, now I'm taking the square root of x to the 3rd power. And the last law is kind of our shortcut law. If I've got exponents raised to another exponent, I have to multiply them. Look at this whopper of a fraction here. We're going to simplify this down so that there's no more negative exponents in this mess. So first thing is, up in the numerator, I see a big monomial squared. So essentially everything has to get this 2, that exponent of a 2, applied to it. So I'm going to do 16 squared, which is 256. Then x to the 5th squared is x to the 5th times x to the 5th, or x to the 10th. Then for my y's, negative 3 times 2 is negative 6, and my z's, 4 times 2 makes 8. So now my numerator here has no more parentheses around it. Now let's inspect the denominator here quickly. No parentheses, but I do see this coefficient here with the 4 to the negative 1. Let's make that into our fraction using our negative exponent law. This is going to be 1 over 4 to the 1st, or just 1/4. And now it looks like we're ready to divide here. So my coefficient's 256 divided by 1/4, or in other words, 256 times 4 is going to give us 1024 for our coefficient. Then my x's, I'm dividing here, so I need to subtract the exponents. 10 take away 2 makes 8. The y's, the bases of y, we've got a negative 6, take away 1, which makes negative 7. And on my z's, 8 take away negative 2 is actually adding the opposite. 8 plus positive 2 makes 10. And looking at this answer, we're almost done. The y to the negative 7th is actually 1 over y to the positive 7th. And there's my answer in simplest form.